So on your test sections for optimization questions, there's going to be one question that is like already graphed for you. The bounded region is already graphed, and it already even identifies the vertices for you. And you're just going to take those vertices and plug them into the profit function and tell me who's the maximum and where does it occur. Then there's a second question in that section where I give you all the constraints, the inequalities, and then you got to graph me a bounded region and find the 4 or 5 or whatever vertices. And then there's a third question where I give you a story problem. It's a fascinating one, probably about farm animals. And it is, you have to set up all the constraints, and then you have to set up the profit function or the optimization function. So at no point on any question are you doing the whole shebang on the test. You're doing separate questions, separate skills. And I want to make sure that when you guys are doing your homework today, that this actually does get done, because this is our last lesson. This is it. Just saw some yays. All right, so this is it, which is good because we're like testing for the rest of your lives next week, aren't we? You guys remember what's going on next week? Review, test, review, test, review, test. How could we possibly forget? All right, so the concept here is linear programming and eventually optimization questions, which is kind of a sneak peek into an idea that you're going to visit in calculus, but in calculus you're going to do this way cooler. So we're going to take an algebraic approach to this concept. So this is an example of when you have what's called a bounded region. It ends up looking like a really weird polygon, sometimes normal, sometimes weird, and that's a case where all the feasible solutions occur within the bounded region. But the ones that are on the vertices are the possibilities for your maximum and minimum. So if this is a application question talking about a business, you want to maximize profit, and then sometimes we ask questions about minimizing cost. So you have to read the question carefully. So here's what we need to know how to do for our homework, our review, and eventually our test. Can you graph a feasible region and evaluate your vertices at the function given to you? So this example, which I believe is on your notes. Is it on your notes somewhere? Right at the beginning? Okay. So this is the, you can either call it the profit function or the optimization function. We're going to come back to that. But right now, what we need to do is graph the bounded region by graphing all these inequalities and creating an inequality system. So, like for this one, did I tell you the wrong page? I'm sorry. Okay. For this one, you're going to want it in y equals form, so I'm just going to subtract the 2x over. So y is less than or equal to negative 2x plus 10. That's what we're going to graph. And then for this next inequality, you're going to subtract the x, and you're also going to divide by 2. So that becomes y is less than or equal to, remember you subtracted the x and divided by 2, so negative 1/2 x plus 4. These bottom two constraints, we call these constraints, they're just restricting you to the first quadrant. X has to be positive and y has to be positive. So you're in this first quadrant, which is all the graph they gave you. Now for your bookwork today, obviously it's bookwork, so you don't have any paper given to you. You're going to want to make sure you have a piece of graph paper from my room before you go. All right, here we go. Blue function starts at 10. And then slope of down to right 1. And because I have such a tough time graphing, I'm going to make sure that I just keep going with my points, because who knows what's going to happen when I go to draw a line. Nothing good, that's what. All right. So if I were to shade this inequality, I would have shaded below the blue line, but I'm not ready to shade right now because I have more parts to my system. Starting with the green part. All right, so up 4, and then your slope is down 1, right 2. Down 1, right 2. And the point where the blue and the green lines intersect is very important because it's going to be one of our vertices. So if you can see that through your intersection, then life is good. Oh man, it's terrible. All right. Ugh. So below the green line, below the blue line, and then positive, positive for x and y, that's going to give you the bounded region, this guy. So the important parts, besides the bounded region, are the 1, 2, 3, 4 vertices that you see. So this is kind of like there's almost an identical test question that you're going to see on Tuesday, where you create the bounded region and then you list out all of your vertices for me. So one vertex is the boring one at 0, 0. And then this guy here is at 5, 0. The one where they intersected was at 4, 2. And then there's another vertex up here at 0, 4. So these are all XY ordered pairs. Your final task is to, and this will be a separate question on the test. It'll be one that's already done for you. So you have the 4 vertices. Now plug them into your optimization function and figure out which one gives you a max and which one gives you a min. So plug it in, 0 for x and 0 for y, you get 0. Plugging in a 5 for x and a 0 for y, you get 15. Plugging in a 4 for x and a 2 for y, you get 12 minus 4 is 8. And then plugging in a 0 for x and a 4 for y, you get 0 minus 8, which is negative 8. So for your solution in this question, they want to know the maximum and the minimum. So you're going to say that you have a maximum of, what is the value that your maximum reached? The actual highest number that I got here was 15, so maximum of 15. And then you have to tell me where it occurs, so at 5, 0. And then you had a minimum of, be careful on this one, there's actually a minimum at negative 8. And that occurs at 0, 4. Now on your test, I think I just ask you about max. So, and that's usually the way it works, because these questions are usually framed as profit functions. So you would like to maximize your profit, of course. All right, so if you feel like you can graph an inequality, that's awesome. I'm going to skip this one because it's pretty much the same thing, and there's one on your homework. And my hope is that we leave ourselves enough time to get going, and I'll actually start your homework with you. How's that? It's just like gifts all day today. Shorten homework assignments. All right, that's fun. All right, let's talk about this question. There are, I know there's at least one on your homework where it's a application like this, and we're going to need to set it up. This is, we're working at a leather company, and they're going to add belts and wallets to the production line. And, oops, didn't want to do that. Oh well. It says belts require 2 hours of cutting time and 6 hours of sewing time. Wallets require 3 hours of cutting time and 3 hours of sewing time. And then there's some restraints here. On cutting machine is only available for 12 hours a week, and the sewing machine is only available for 18 hours a week. And then they give you some clues about profit and how much you're going to make off each product. So this is very similar to your test question where it's a story problem. I went ahead and told you what you have to use for variables and what they represent. I did the same thing on your test. So it says let x equal the number of belts and let y equal the number of wallets. So first thing they wanted me to come up with is the objective function, which you guys can also write as the profit function. That's another way of saying what we're about to write down. So that would be all the profit stuff here. So it says the belt will net $18 in profit and the wallets will net $12 in profit. So all those clues together with the variables that are already set up for you says that it's $18 times each belt plus $12 times each wallet. So this question, I think on your notes, the follow-up stuff is already done for you, but on your test, once you get the profit function and the constraints set up, that's all you're going to have to do on the test question. There's no further action. But that's not true on your homework. On your homework, you got to do everything. So the constraints, they already gave you 2 constraints that were like obvious. You can't make negative belts and wallets. So it says x and y have to be greater than or equal to 0. And then there's some constraints about time, and they kind of gave you a hint here. The cutting time, if I go back and look, belts require 2 hours of cutting, and then over here it says wallets require 3 hours of cutting. So belts were the x, so 2x plus 3 times y, and then they already filled this part out for you. It has to be less than or equal to 12 because it says the cutting machine is only available for 12 hours a week. So once you add together all of your cutting work, it can't exceed 12 hours. And then another similar set of questions or clues here. It says 6 hours of sewing time for a belt and 3 hours of sewing time for a wallet. So 6x plus 3y. And then again, the sewing machine's only available for 18 hours, so less than or equal to 18. So on your test on Tuesday, this is what you're going to have to come up with. I'm going to give you variables. I'm going to give you a story problem. I believe it's about animals. I forget. But then you're going to set up I'm going to give you the two obvious constraints. You're going to give me the profit function, and you're going to give me the two other constraints. So they already did that for us. That's wonderful. Thank you. Let's move on to, there's a little blurb in your notes about sometimes there's no optimal solution, meaning like there's no maximum or there's no minimum if that's what you're trying to do. So in those cases, basically you need more parameters in your problem if it was like a real life question. There was originally one on your homework that was real funky, and that was number 12 that we already crossed off. Turns out when you tried to do number 12, you got this bounded region that, well, it was unbounded was the issue, and it like extended forever, which I don't know if there's an example like that on your notes here. We're going to come back, but like this example here, if we kept shading, like it goes on and on and on. So depending on what your profit function is, maybe there was an issue with there was no maximum because it just kept going on and on and on forever. All right, so we're going to kind of, for the sake of time, skip over that concept. This question, where is it? Right there. This is the one I want to look at. So this one, nothing's done. All they did was give you a whole bunch of information, but at least they were super sweet and they put all the information into a chart. So that helping, like, let's be honest, guys, when you hit a story problem, some of you skip them every time, and I know you do, but now that you're in upper level math, you kind of have to get over that. Story problems are not, like, you got to just dissect the story problem. In math, questions usually end up at the end of the story problem. Maybe you luck out and they give you data in a chart. That's awesome. Otherwise, your job is to kind of filter through the paragraph and look for things that should go together in an equation. This one's already sorted for you. So we are making ice skates and roller skates. And it tells me all sorts of things, like how long it takes to assemble and package them. It tells me how much profit I make on each product. It tells me how much time I have available because of how many workers are working or machines are working. So let's start with write an objective function. Remember, that's fancy talk for profit function. But before we do that, you guys don't even have variables assigned yet. But I do notice they're going to ask me to graph in a minute. So because of the graphing component to this question, let's just stick with X and Y. And what are some things that I do not know? For instance, some things I don't know. What would you like X to represent? What about roller skates? What do we not know? Number, yes. Number of, and I'm assuming these are pairs of roller skates, but we'll just say number of roller skates. I know what you mean. So then Y must represent the number of ice skates. So using those variables, when I go to write the profit function, I always call it P of XY, but you can call it whatever you want. There's a clue right here that says $30 profit on each pair of roller skates and $40 off of each pair of ice skates. So when we get to the end of the question and we have our critical points that are on the vertices, we're going to plug those back into that red function, but we are not there yet. All right, let's talk about some constraints. I am going to not have enough room, so I'm going to write down here. This is going to be the last question we do in the notes, so you guys can use whatever space you want to use anywhere else on the notes, okay? So let's talk about constraints. The first constraint is about this assembling process. Every pair of roller skates takes 5 minutes and every pair of ice skates takes 4 minutes, and you only have 200 minutes of assembling time because of your workers or machines or whatever's going on. So that's actually your first constraint. Using your variables that y'all set up, 5 times X plus 4 times Y, and then you have up to 200 minutes. So what inequality symbol should I put here? Less than or equal to 200. Very nice. And then similar constraint equation, or inequality, excuse me, for this guy. When you're checking and packaging the product, it takes 1 minute for a roller skate pair. It takes 4 minutes for an ice skating pair. And then again, you have up to 120 minutes, so less than or equal to 120. Now, there's some natural constraints we haven't talked about. You can't make -5 roller skates, can you? So X must be greater than or equal to 0. And then same thing with the ice skates. Can't have negative ice skates either. So we have to graph this, which is bad news for me because you've seen the graphs. I'm going to need to rearrange this green one. I like to graph inequalities in slope-intercept form. So I'm going to subtract the 5x over. I'm also going to divide everything by a 4. So when I do that, so I subtracted the 5x and I divided by a 4. And then I took 200 and divided by 4 as well, so that's plus 50. And then similar work here on the blue function. I need to get that in graphing friendly form, slope-intercept form. I'm going to subtract the x and divide by 4. So I subtracted the x and divided by 4. And then I took 120 and divided by 4. So the x greater than 0, y greater than 0, I wrote them down, but they kind of already gave that to me because look at the graph they provided to you. It's only in the first quadrant. So that's, yeah, makes sense. All right, here we go. Let's try to graph. So starting up here at 50, your slope is down 5, right 4. This is kind of bad news because I'm not going to be able to see where they cross. So I'm going to show you what you have to do in order to find the intersection point if you're not real sure. In other words, if you graph like me. So, oh, okay, that was a bad start. Try again. Boy. All right, blue one starts at 30. And your slope is down 1, right 4. Oh gosh, I did a terrible job of graphing that. I'm going to go steal that shape tool pen. Remember that guy? Yeah, I'm stealing that. There we go. That's better. I saw you giggling at my line. All right, so down 1, right 4. Yep, good enough. Okay. So after we figure out this polygon, it turns out to be this dude. And 3 of these vertices are very obvious to me. This is the one I'm having trouble with. Now, I could make a guess. And even cheating, using a shape tool, I still have a bad graph. So what I'm going to need to do is I'm going to have to do a little side algebra, and I'm going to have to figure out where those functions intersected. So what you're going to do is take the body of the green function and set it equal to the body of the blue function. So in other words, you're going to set up negative 5/4 x plus 50 and say it's the same thing because they're intersecting negative 1/4 x plus 30. And I'm supposed to solve that, and y'all know I hate fractions, so goodbye fractions. I'm going to hit everything by a 4. So we have negative 5x plus 200 equals negative 1x plus 120. And then your choice how you finish solving this, but I'm going to add 5x over. So that means I'm going to have to subtract 120. And what do we get here? So I found out that x equals 20. And if I go back and look at my graph, you know, I feel a little better about myself because I probably would have guessed that x equals 20 just because I know how badly I graph and I was probably a little off. But guessing is not good enough in this case, guys. You must find the intersection point. There was other ways to find the intersection point, and we actually aren't done yet, right? X equals 20, so now you got to plug a 20 in to like right there to figure out y. So if x equals 20, you get negative 5 plus 30, so y equals 25. And maybe you guys graphed beautifully, and you could absolutely be certain that your intersection was at 20, 25. I was not in that boat, so I had to go find it algebraically. I could have also went back to this version of it, pretended like they were equations, and done elimination to solve the system. That would have worked too. Either way, the point was you had a little algebra to confirm that the intersection point was where it was at. Guess what, guys? That intersection point is totally going to be your maximum, I bet. So let's go figure it out. If we plug in all these ordered pairs, and this is 20, 25. If we plug in all these ordered pairs into our profit function, that guy we found a long time ago, let's see here. I need more space. 0, 0 gives you nothing. Big shock. 40, 0 would give you 1200. 0, 30 also gives you 1200. But if you plug in x equals 20 and y equals 25, do you get 1600? Could someone confirm that? Plug in x equals 20 and y equals 25. I love your trust of my mental math, guys, but this is not a good moment to trust anything. It's Friday. I'm tired. Is it 1600? No? No? Nobody? Yes? Okay. Are you just agreeing with me? No, okay, that's a bad idea. All right, but it is the maximum. I know that for certain. Apparently it's 1600, and if we're wrong, that's because my kids are too lazy to type. All right. Embarrassing me on the internet. So, oh, by the way, I kind of skipped this part because I'm tired. But on the test, I'm going to ask you to write a sentence. So you would say maximum profit of 1600 when they make 20 roller skates and 25 pairs of ice skates. All right. So put the lesson, well, off to the side. And on your homework, which remember we adjusted our homework. If you are watching from Mrs. Hoffbauer's class, I do not know if she adjusted it the same way, but it is page, oh geez, I already forgot, 40 something? 410, never mind. And it used to be numbers 9, 12, and 29. Now, my first hour friends, we did number 12 together, but if you for some reason didn't write it down, in third hour, we're going to switch that out for number 3, because it's better. Yay. You're going to want graph paper. All right, so switching out that terrible question for a number 3. This is very similar to something that you would see typically on a test for pre-calc. Number 12 was unusual and strange, and I figured if anything else, you guys would just make me do it Monday morning anyways, so I just said, let's scrap that one. All right, so number 3, they give you an optimization function. That's this guy. So you're not going to graph that. That's something you're going to use to evaluate your vertices at the end of the problem. But we do need to graph all these other ones. So the last 2 inequalities are fine, but the first 2 we need to rearrange so we can graph them really effectively. Now on your graph paper, you need to make appropriate axes when you get to that level. We'll talk about that in a minute. But you want to be able to graph really accurately. So if that means using a ruler or the side of your calculator to get a straight edge, please do. So here I'm going to subtract the x and divide by 2. So this inequality becomes y is less than or equal to negative 1/2 x plus 3. Now be really careful on this next inequality. You're going to subtract 2x, but you still have a negative in front of the y. So I need you guys to pull out a rule from long time ago algebra. What happens on our next step when we divide everything here by a negative 1? The sign, the sign reverses. So this inequality actually becomes y is greater than or equal to positive 2x minus 7. So I'm going to need you to super carefully graph these 4 inequalities. So make sure that your axes are going far enough so you can graph the pertinent pieces. So like for instance, this one has to start way down at negative 7, so keep that in mind. Okay, so after an excruciating round of graphing, you should get something that resembles that, but obviously yours looks much prettier. And then you guys are going to identify the location of all 4 of these vertices. And then remember you have that profit function from the beginning. So you got to go back, which I forgot what the profit function even was. What was it? Oops, wrong one. It was, oh, easy, x minus y. So once you compute x minus y on all these, they want you to identify both a maximum and a minimum, where they occur and what they are. Okay? So try to get to a good stopping point on that question, and then I'm going to help you walk through the next question that's assigned, which is number 9. And 9 is a story problem. Of course it is. Yes. Okay. Let's look at that. So it was supposed to be everything less than the blue line, but then it ended up being greater than the green line, because remember we reversed the sign when we divided by a negative 1. Okay. Does that answer the question? Greater than means above. So if I think about like if this was a skateboard and I was trying to jump on top of the skateboard, this is the above it. If that's hard for you guys to visualize, like above the line, below the line, you can always test a point. So like if you tested 0, 0 in that inequality, it would come out to a true statement, which means I would shade towards 0, 0. Okay? And then greater than this line and greater than this line. That's how we ended up with that beautiful, weird quadrilateral. All right, so I'm going to let you finish that question, but I would love to look at number 9. So number 9 in your bookwork is a like 3-part story problem, and the first part says to create the profit function or the optimization function and also the constraints. So it's about a medical receptionist, and she's trying to schedule checkups and physicals for her doctor's patients. And it says, One of her tasks is to schedule appointment times. She has 20 minutes for every checkup and 40 minutes for every physical. And then there's some restrictions for the doctor. He can't do more than 6 physicals per year. And then the clinic is only available for 7 hours during this time. So there's a time constraint. And then they give you some information about money, which is usually a dead giveaway for that's probably the profit function. So our profit function, which you can call whatever you want, but I always call mine P of XY, is going to be, now we haven't set up our variables yet. The 2 things that we don't know in number 9 are the number of checkups and the number of physicals. So this doctor charges $55 for every checkup and then $125 for every physical. So that's the function that we're going to come back to at the end of the question. But now we get to have fun with constraints. So, obviously, the doctor cannot say that they performed negative visits. That would be weird. And then the other clue talks about time, and it says it's going to take 20 minutes for every checkup and 40 minutes for every physical. And when you add up all the time spent with the patients, it can't exceed, now be careful, it can't exceed 7 hours. These were measured in minutes, so you need to multiply, what was it, 7 hours by 60 minutes, and that's, you're going to say, has to be less than or equal to 420 minutes. And then there's one more clue. It says that the doctor can have no more than 6 physicals scheduled per year. So the number of physicals has to be no more than, so less than or equal to 6. So what you're going to have to do on this one is just like we did on the previous question. Now that we're all set up with algebra, you're going to want to rework this green inequality into graphing form. So you're going to subtract the 20x and divide by 40. So subtracting 20 dividing by 40 would be negative 1/2 x plus, and I think this comes out weird, like 10.5 or something. Is that 10.5? 420 divided by 40? So the graphing on here, I'm not even going to attempt it. It's going to be awful. You're going to want to graph very carefully, and you might have to employ that technique where you figure out where they cross through setting the functions equal to each other. However, this one's not really too bad because the other function just says y equals 6. So if you're trying to figure out where they cross, all you got to do is put a 6 in for y and then see where it solves, basically. Anywho, I'm going to leave you alone on that question because, yeah, I'm not going to be able to do that one. You guys need to find your vertices, and then you got to figure out what, I'm sure they want to maximize something. So part C says, how many of each appointment should Olivia make to maximize the income, and what is the maximum income? So basically, they're just asking you to finish the question. So I'm going to give you a little bit of guidance on 29. I think it's important to start with what your variables represent. And it's kind of hard to figure out like what exactly they want you to solve for in 29, but they're looking for the number of batches of each type of juice, or whatever they're making here. So X is the number of batches of mango, is just what I went with. And then Y is the number of batches of strawberry. So I think with so much information in a problem, it's nice to just pull some of the information out of the problem so you don't have to worry about it anymore. So right away I write the profit function. And that was $16 for every batch of mango and $12 for every batch of strawberry. Then they start giving you some constraints. So it says it uses, oh, you know what? Back up, Abruzzo. Mango juice. This is a little confusing because they're like making specialty drinks at like an Orange Julius style place. Okay. So let's not use the word batches. I think that's confusing. I don't even know what they're labeling this as. Probably liters. I bet it's number of liters. Sorry. Okay. Okay, anywho, so it says, A batch of mango sunrise uses 3 liters of mango juice and 1 liter of strawberry juice. You know what? I don't know what those variables represent. This is really weird. I have to think about this question a little more. I guess my days of Baskin-Robbins are fading away. I don't remember how this is working. Anyone interpret that? I know this font is really tiny. I don't know. I can't figure out what they're measuring in that question. Anywho, whatever. So use your gut instinct on this question, guys. As far as like what it's going to set up. 3 liters of mango juice. So 3 liters of mango juice. And then 1 liter of strawberry juice. Oh yeah, keep reading. Back up, Abruzzo. This is not at all the function. You know what? This is a good lesson, children. Read the whole problem before you start writing stuff down. The next sentence says, the store has 40 liters of mango juice. So you're restricted to only so much mango juice, right? So we only have up to 40 liters of it. And I have no idea what this is supposed to represent. I'm just going to erase all of this. I have no idea. I'll come back to that in a minute. All right, 40 liters of mango juice. The first drink uses 3 liters of mango juice, and then the other kind of drink uses 2 liters of mango juice. So 3 liters of mango juice plus 2 liters of mango juice. Okay, I think I figured it out. This represents the number of batches, I was right the first time, excuse me, of mango sunrise. I apologize. What's the name of the other drinks? No, not that. Oasis Dream. Why not? Gosh, why did that take me forever to figure out that? Ugh. Anywho, let's talk about strawberry juice. We have 15 liters of strawberry juice. And then Mango Sunrise uses 1 liter. And then, where's the other one? Oasis Dream uses 1 liter as well. Whew. Okay, I think I better stop. So, now that we have the 2 algebra constraints, you're going to need to solve for them. You got to graph them. And of course, guys, if you're not making any batches of anything, you're not going to make any money. So I don't think your maximum is going to occur at 0, 0. Graph carefully. If you don't graph carefully, you got to use algebra to figure out where they intersect. All right, you're almost home free.